Okay, so which figure does not belong? Okay, ready? Turn and talk to your partners, your people at your tables, and discuss which one you think does not belong, because it's going to be different. There's some of them that you are going to think differently. So ready, go. No, it's good to just visualize. You're just trying to figure out. It's okay.
I can say anything because they all look like they could.
Right.
They can for sure hold on. I'm just saying.
Okay, so team one, give me something that, which one do you think does not belong? It can be any of y'all. You said one because they didn't grow or shrink. One didn't grow or shrink. Okay, team two. Okay, set 4 only takes one transformation. Okay, 3, team 3. Okay, so he said all of the other ones are shapes and those are just lines. Okay, team 4. Set what? 3 is the only one that gets smaller? Okay. Set 2 didn't get smaller?
Set 2 got bigger.
Oh, set 2 got bigger. Okay, got it. Okay, team 5.
So you said set 1 because it's the only figure that wasn't dilated.
It's the only figure that wasn't dilated. Okay, so let's discuss this a little bit. So set 1 is the same size. They're congruent. Set 2, the dilation enlarges. It's the same shape. Set 3, they're not facing the same way, and the dilation shrinks. And then set 4, the shape is together. So you have the same shape, but they're in the same, they're not two different shapes. They're like combined, okay? So good observations. Now I have a question, and I want you to think about it this way. What rigid motions or dilations can we apply to map the original figures onto the images? So what rigid motions, we're on the same page, what rigid motions or dilations can we apply to map the original figures onto the images? So I want you to take about a minute or so and discuss. Maybe one person from each, one person pick each image and figure out if you can figure it out, and then talk about it. Ready, go.
Series of transformations and things that not figure out what
Okay, ready? Here we go for team points. Team 5, what would you say about set 4? Team 5, what would you say about set 4?
A dilation with a number greater than 0 and at point K.
Okay, so a dilation with a number greater than 0? Any number greater than 0 would make it bigger, but 0 to 1 is smaller than 1, right? A number greater than 1. Okay, cool. So a dilation of a number greater than 1 with the dilation point at K. Ready? Team 4. What about set 2? Dilation and reflection. Good observation. Team 4. Okay, team 2. Number set 1. Just the translation. And I'll come back to y'all. Team 1. What about set 3? So it was a dilation and a rotation. Good job. Team 1. I almost fell off the stool yesterday, putting points on the board. Backwards. It would have been awful. Okay. So the last question that I have is set 1, we can only apply a translation, which is a rigid motion. And what do we call the figures for which we can map one figure onto the other by a rigid motion or a sequence of rigid motion? Like, what makes them so that we can map one onto the other just by translation? Team 3. Why can I do that? They're congruent shapes. Good job, Team 3. Okay, here we go. Ready? This is going to be super hard. You ready? Totally joking. It's not hard at all. Okay. So look at the next page. Let's see. I can see. Oh, I can't see now. Okay, here we go. So we're just going to discuss this. We're not going to do a bunch of work. We're just going to kind of figure this out. So let's look at triangle ABC and triangle ADE. We are going to figure out what information we can use in order to find the scale factor. So what information can we use in order to find the scale factor? Anybody? What you got, Ryan? Length of the bottom. Okay, and what triangle maps onto the other one? What tells us that? Okay, so everybody look and pay attention. This is where we need to pay attention. ABC is going to become ADE. So they tell you what order we're moving in. Got it? So first off, I'm going to teach you how to do something, and it's going to be very much important. I'm going to do it in the next step, but I want you to look at it this way. We're starting here, then going this way. Okay? So this is our original, this is our image, original image. We good with that? There goes my book. So, what we are trying to figure out is what is our scale factor. So I want you to spend about 30 seconds and see if you can discover what the scale factor is. You can work as a group. Go.
It's just 8 divided by 2.
Okay, so ready? Which triangle are we starting with? The smaller one or the bigger one? Smaller one. Okay, so what's the length of the smaller side of information that they gave us? 2. So our original is AB, and its length is 2. What is my image? Which one's my image? The big one, right? And what side is that? DE. What's the length of DE? 8. Okay, so which one's my image? DE divided by my original, which was AB, which was 2. Sorry, did I do it wrong? I did do it wrong. BC, my bad, I made a mistake. Okay, so ready? 8 divided by 2 is
4.
4, so my scale factor is 4. We okay with that? Yes, ma'am. Yeah. Any questions? We okay with that? Cool. Ready? Let's go to the next one. They tell us that triangle MAT is going to be similar to triangle PIN. So, big or small? Which one's first? Big to small. Big to small. So we're starting with this guy and then we're going to this guy. So what's going to happen to make this become this?
Translation
Okay, so we're saying two things. We're saying dilation and we're saying what? Translation. So here's your rule. Everybody write it down, put a star next to it. That way you can make sure that you are making sure that you're not skipping this. Ready? I wrote myself a note so I didn't forget to write it to you. Tell it to you. There it is. Okay. Always. Always dilation before transformation. And I'm going to explain why. In some cases, it will work to move it and then shrink it or grow it. In some cases. But not in all cases. So in order to make it easier on yourself, always dilate, make the shape the same size. Then move rigid motion. Okay? Are y'all okay with that? So always dilate it, shrink it or grow it, and then move it. It will make your life so much easier. Okay? So in this case, we would dilate, then translate. Turn the page. Well, y'all don't have to turn the page. I have to turn the page. Let's look at number 4. So I want you to figure out what rigid motion would map LMNO because it is similar to PQRS. So what is our mapping? Y'all can discuss it. Who thinks they have an answer? Oh, put your hands down for points. Who thinks they have an answer? Bentley had his hand up first. Okay, Bentley, what you got? Say it again. That's it? Anybody disagree with him? What do you have, Jordan? Okay, who agrees with Jordan? We have to translate too. So he is rotating 90 degrees, but don't forget that he's moving as well. Turn the page. Told you we was going quick. Okay, this is where it gets meticulous. And this is where you're going to do like 3 problems, and you're going to have to write all the pieces of information, and it's going to be a lot of things, but it makes it a lot easier whenever we get to understand. Okay. So they're telling us that triangle DIG is similar to triangle FAN. So we have our dig triangle and our fan triangle. I just think it's funny when they spell things. Okay. But what we're trying to do is we're trying to figure out what is happening and what's the scale factor. So what we are going to do is we are going to label every vertices, meaning we're going to find the coordinates for all of them. Okay? So we're going to start with D, I, G. For points, who can tell me the coordinate of D? Christopher had his hand up first. What you got? -3, 7. I. Cooper. -3, 3. Vetica. -6, 3. Okay, and then we're going to figure out F-A-N. F-A-N. Bentley, your hand's already up. -6, 14. Carter. -6, 6. Addie. -12, 6. Okay, here we go. So now we need to figure out that the way we're describing the mapping matters when we're using scale factor. So if you put the wrong thing, then something's going to happen. Let's go with what they said. So they want to know DIG to FAN. So which one's my original? DIG. I'm going to put a big O at the top. That way I remember that it's my original. Which one's my image? FAN. Okay, and how do we figure out scale factor? I over O, right? So, here we go. This is where it gets really annoying. And y'all are going to be like, Miss Cody, do we have to do all of them? Yes. You have to do all of them. Just to double check yourself. Ready? So, D, what was my original? Pick one. It doesn't matter. -3, 7. Do you want to use your X value or your Y value? -3. Okay, so I'm going to put -3 right here. And that's going to be my D. Which one corresponds with D? F. Okay, so we use the X coordinate. Now we're going to use the X coordinate of what? F. What's the X coordinate of F? Negative what? 6. Okay, what's -6 divided by -3? 2. D and F are done. Now we're going to do I. I know. It's okay. I'm going to put A over I because I already know that that's how it's going to work. So A is -6. I is -3. Is everybody understanding what I'm doing? Okay. What's -6 divided by 3? -3. 2. Now we're going to do G and N. So, ready? We have N over G, which is going to be -12 over -6, which equals 2. Did we get 2 every time? That is your scale factor. What would happen? What would happen if it switched? What would happen if the scale factor, so what would the scale factor be? If triangle FAN was similar to triangle DIG. So I'm going to give you about a minute for your team group to solve. Oh, I'm sorry. What would be the scale factor if triangle FAN was similar to triangle DIG? So if they swapped, they were opposites. So if my big triangle became my small triangle. What'd y'all discover?
R equals 1/2
Why would it be 1/2?
because I'm using f x power -6, which is the original,
Okay.
d x y -3, which is the image, and I put -3 over -6, and that is 1/2.
Okay, so if we take the opposite, it's going to be 1/2. Also, another way to look at it is if you have a big shape and it's going to a smaller shape, it's going to be a number less than 1. We okay with that? Turn the page. This is it. This is it, guys. This is the one that you're really going to be like, that's good. You're like, yep. So you're right now, while we're writing, you're going to write all of it out, okay? So, what is it asking you to figure out? They want to know in the diagram, figure A, B, C, D, E, F, and it is similar to G, H, I, J, K, L. So, what you are going to do is you are going to figure out the length of each side. Go. Both shapes. Go.
The length?
The length of them.
The coordinates.
The length of them. The length. The length. Each side. The length of each side. Go. Didn't say it was hard. I just said it was tedious. Not yet. Okay, now we need to figure out what sides match what. Ready? So, we have figure A, B, C, D, E, F, and G, H, I, J, K, L. So, we automatically know if we're going from a smaller to a bigger, our number is going to be what? We're going from smaller to bigger. Greater than 1. So I'm going to put that as a note. Greater than 1. I know it's going to be greater than 1. So I know that A, B equals 2. I know, you're going to write this with me. I'm sorry. B, C equals 2. D, E equals 2. E, F equals 4. And F, A equals 4. I also know that GH equals 3, HI equals 3, IJ equals 3, JK equals 3, KL equals 6, and LG equals 6. So I'm writing all of my parts. And we're trying to figure out what maps what. So we need to put the image over the original. I'm going to show you a trick. Ready? Look what I wrote. I know it looks really intense. It does. But watch. Really cool. So it's going to tell me what I need to put on top of what. Watch. If I cover, I need something cool to cover. It's not really going to cover it. It's just going to make it look like it's not there, sort of. That means that I'm going to put GH over AB. So look at our sides. GH over AB. What's the length of GH? 3. What's the length of AB? 2. Okay, let's do the next one. So we don't need GH anymore, but we need the other side. So now we have what? H what? HI over BC. What's HI? HI was 3. BC is 2. Okay, my next one is going to be IJ over CD. What's IJ? 3. What's CD? 2. Good job. Okay, what is JK? 3. What is DE? Okay, ready? What is KL? And what is EF? Uh-oh, we have 6 over 4. Is that the same as 3 over 2? Is it? It is, simplified. So 6, 4 is 3, 2. Then we have the last one, which is going to be LG over FA. So 6 over 4, which is 3 over 2. What is the ratio of each side length? What's the ratio? What's the scale factor? 3 over 2. And what do you notice? The scale factor is the same for all of them, right? Oh, so compare the measure of each angle in the figure to the measure of its corresponding. What do you know about the angle measures? What do you see about the angle measures? They're all the what? They're all the same. They all match. It doesn't matter if the shape is really big or the shape is really small. Right? It's the same shape. Yes? Okay, so what I want you to do is I want you to turn to page 170. Page 170. And we're looking at number 7. Number 7. And we're going to look and see how are we going to map our ST onto MNO. We're on number 7. And our job is to figure out what transformation, which rigid motion or dilation or both maps one onto the other. We don't know that yet. All we know is that one similar is to the other one. So what I want you to do is I want you to spend about a minute or two talking with your group of how you would figure this out. Ready? Go. Okay, so let's talk about this one. What rigid motion is going to map this one? What you got, Bentley? A dilation and translation. Can you tell me the dilation and the translation, though? Uh-huh. The numbers. We need to know how to do the numbers. That's where we need to figure out what's going on. So, 112 what? What's the first thing I told y'all that we had to do? Find a what? The side length or the... Can we figure out the side lengths for this one? Is it on a straight line? No. What do we need to use then? The what? We could use the Pythagorean theorem, or we could use it's on a graph. Coordinates. You can use the coordinate points. So, ready? We know that we have R, S, T. R is -3, 0. S is -5, 6. T is 0, 3. Then we have M, N, O. M is 4, -12. N is 0, 0. O is 10, -6. Using the new information that you have, I want you and your groups to spend about a minute and a half and try to see if you can figure out what the scale factor is. What the scale factor is. Ready, go. Okay. Are you sure? After y'all finish the problem.
The translation is square root of 18.
You can't translate the square root of 18. It's a number. Okay, so are we going from big triangle to small triangle or small triangle to big triangle? Small to big. Okay, so if we're going from small to big, then we need to know that we are going from this guy to this guy. Ready? What is our translation? What is our dilation? Said the wrong word. 2? How?
6.
Wait, what did you do?
I put the image over it.
So, you drew triangles though. Show me how you did that.
I did this to find the center lines, and then 6 over here, 6 over here, 3 over here, 3 over
So,
here.
this is what Carter did. Just because I think it's cool and I want to share it. He went like this. This side length is 6. This side length is 3. So then he took his his image, and put it over his original, which gave us 2. So that's one way to do it. Another way to do it would be to do what? Take your points that you have. So M and R. M and R. What is M? It makes it harder to find, right? So I like the idea of doing it this way because it shows you an easier way to do it. Could you have done it from another side? Could we have done it from another side? Let's see if it would work. From every single side. So let's look. What's M?
It's 4.
There's 4. And this is 2. So what's 4 divided by 2? 2. Okay, this is 12, and this is 6. What's 12 divided by 6? 2. So that's just a good way to be able to look at it. Everybody say thank you, Carter. Good way to look at it. Okay, now that we know the dilation, we dilated it, it got bigger. Now we need to figure out the translation. The translation. Can I show y'all a way to do it? Okay, ready? So if we're going from S to N, how many units right are we moving? 5 units right. And how many units down?
6.
Ready? So I'm going to go from S to N. I just chose that one. But could we do R to M? Ready? Let's count. 1, 2, 3, 4, 5, 6, 7. Well, that's weird. What do we do? Down. Okay, so down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm on the wrong one. So I have a question. How much was this one? It wasn't 10. It was how many units? 7. So how do we figure out how to translate it?
We dilate first.
Dilate first. And when you dilated, what happened?
this is,
That's why I struggle with translation.
Watch. Hold on. So if we have if our scale factor is 2, what's negative 3 times 2? Negative 6, comma, what's 2 times 0? Okay, what's negative 5 times 2? What's 6 times 2? And what's 0 times 2? 3 times 2? 6, 0. Negative 10 would be over here. 12 is way up here. Uh-oh, we have a problem. And then we have 0, 6. Okay, so there's our triangle if we dilate it. Now we're trying to figure out how to get it in this spot. What do we need to do in order to get all of this into this spot? Huh? Say it again. 10 units right, 12 units down. But this is the actual translation. So explain that. Okay, hold on. There's an idea. Okay, so we're translating 10 units right, 12 units down. Does the scale factor have something to do with the translation if this is the original translation?
it's 2,
What do you mean it's 2?
5 units
Times 2 is
times
10. 6 units times 2 is
10.
12. So if we're moving him 10 units right, 12 units down, we're going to end up matching these points. But if you take the original, which is the tiny one, it's 2 times smaller, right? So what's happening is we're actually translating our dilated. So we're translating. We can translate then dilate if we wanted to by matching points. So this guy moved here, came down. So we went 5 units right, 6 units down. Then they dilated. However, if we dilate first, then it allows for a different transition. So we're going to do another problem.